The third lesson actually studies parallel lines. Now, before we embark into this lesson, it is important to take some time and understand what parallel lines actually mean. Suppose that I have a line here which I can call line AB. Then I have another line here which I will call line CD. In order for us to geometrically represent parallel lines, we actually use a small arrow like that to say these two lines are actually parallel to each other. But what does parallel mean? Well, one of the original postulates of Euclid is that if we have a line like AB here, this line will continue going on indefinitely until infinity. It doesn't stop. And the same is actually true with line CD. It will continue like that indefinitely until infinity. Now, when that happens, these two lines will never cut each other if they are parallel to each other. So parallel lines means exactly that, lines that will never cut each other. So as they continue extending like that, they'll never cut each other. If they behave like that, we say they are parallel lines. Now, what does that mean? That actually means that if we look at the distance between these two lines, it's exactly the same. So if we were to look at the distance from here to here, and look at the distance from here to here, and the distance from here to here, it's exactly the same. We get the same distance, D. It's the same number. That's why these two lines will actually never cut each other, even if when they extend until infinity like that, because the distance here is always maintained to be the same. Obviously, you can clearly see that if I were to have a line that goes like that, and I have another line that would go like this, and these two lines are not parallel, we can see that if we extend these lines like that until infinity, and we extend this one as well until infinity, at some point here they will actually cut each other, and that's why they're not parallel, and this side they just go apart from each other. This happens because the distance between these two lines is actually different. So here we'll have a distance, let's say D, but here we'll have a distance R. So the distance this side is bigger than the distance this side, and therefore these two lines are not parallel, and they will cut each other. But with parallel lines, they'll never cut each other. Now let us incorporate this into Theorem 4, which says that lines that are parallel to the same line are parallel to each other. Obviously, we know by now that a theorem has two parts to it. So the first part is the fact that we have lines that are parallel to the same line. Hence, our short version of the theorem quotes exactly that line, that statement, to say lines parallel to the same line. That is the A part, is like our given information, is what we know in this theorem, is the A part. Then the conclusion here is that these lines will be parallel to each other. These lines will be parallel to each other. So that's what we conclude, and we call that part B of the theorem. Now, to understand this theorem in terms of looking at the geometry of it, let us look at the diagrams below. Now, in this very diagram, we are saying that if we were to have, line 1 parallel to line 2, that means this line here being parallel to line 2. You can see here we have these lines here, the arrows, to show that these two lines are parallel. And we also have line 3 being parallel to line 2 as well. Right? So you can see in this situation that we have these two lines L1 and L3 being parallel to the same line. So they are lines parallel to the same line, right? If that's the situation, we can then conclude to say, therefore, line L1 and line L3, they must also be parallel because they are parallel to the same line. Now, another way of looking at this is to acknowledge the fact that if we say if we say line L1 is parallel to line L2, it means they will never cut each other. The distance here is the same distance D. And also when we say line L3 is parallel to line L2, it means the distance here is the same. Maybe it's distance R, but it's the same between them, is maintained. By default, the distance between these two lines, L1 and L3, must also be the same. Let's say maybe here we have distance P. It must also be the same, because if these two don't cut and these two don't cut each other, it means also these two can never cut each other. I mean, this is different to the fact that if, let's say, L1 was going like this, it will cut L2 here. And you can see already that it will also cut L3 somewhere there. And vice versa, if line L3 was doing that, it will cut this line and eventually it will cut that. But because, these two do not cut and these two do not cut, it therefore means this one and this one should not cut each other. I hope this theorem makes sense because, it's a very important theorem that we will need in order for us to work with quadrilaterals and also circle geometry for grade 10, 11, and 12 respectively.